Before you build the robot, make sure you watch this video right through at least twice. Make sure you have an electronics grade soldering iron and that you are capable of high quality soldering. I would also suggest that you do a Google search and find our video that teaches you how to do high quality soldering. The first step is to cut the tabs, joining the various printed circuit boards with sharp side cutters or a fine file or a saw blade. File the remaining sharp points on the edge of the printed circuit board flat with sandpaper or a small file, taking care not to damage the printed circuit board. Once you've separated the printed circuit boards and removed the sharp points, you will want to use a ball of press stick to roll up the dust. One of the first things we do before we do anything else is we use some electrical insulation tape to mask off the printed circuit board before placing the resistors. What this means is only the two inner rows of holes are visible, and this will prevent the resistors from being placed incorrectly. The printed circuit board can be destroyed by removing wrongly placed parts. First, you want to find the 220 ohm resistors and place 14 of them on the printed circuit board over the silk screen markings. Placing a small box under the printed circuit board means there will be somewhere for the leads of the resistors to go when you push them through the board. You will need an electronics grade soldering iron. A soldering iron that is too hot will damage the board and the electronics. So you want to find that sweet spot where the soldering iron works well, where it's not too cold and it's not too hot. If you have a soldering iron with a base station with a digital display, set your soldering iron somewhere between 340 degrees Celsius and 360 degrees Celsius. If your soldering iron doesn't have a digital temperature readout, you're going to have to use a little bit of trial and error to find that point at which the soldering iron is not too hot and not too cold. I would advise you to watch our how to solder video and to do some practice soldering on inexpensive electronics kits or junk electronic parts before you tackle building the robot electronics. One of the things you want to do is have a decent stand for your soldering iron with a wet cellulose sponge that you can wipe the tip of the soldering iron clean every time you pick the soldering iron up before you apply it to the board. If you wipe the soldering iron every time you pick it up, you will have a perfectly clean board by the end of this build. Once you have all the resistors in place, you can turn the printed circuit board over and untangle and bend the resistor legs slightly apart so the resistors don't fall out the printed circuit board when you turn it over. You will want to lie the flipped over printed circuit board flat on the work table so the resistors are pushed flat up against the printed circuit board when you solder them in place. Only solder one side of each resistor and then flip the board over and check that each resistor is straight and in its proper place. Then solder the other leg and clip off the excess length of wire. Now you can place the 1 kilo ohm resistors and 10 kilo ohm resistor on the printed circuit board. The 1 kilo ohm resistor can be identified by looking for the resistors with brown, black, red and gold stripes. The 10 kilo ohm resistor has brown, black, orange and gold stripes. The diode is a small black cylindrical part with a lead out of each end. It is critical that the white strip on the printed circuit board, silk screen, and the silver band on the body of the diode are inserted the same way around. Now you can fit the 6-way USB header near the power switch. You can hold the part in place while you solder it with a tiny blob of press stick. Touch the soldering iron on both sides of the board to make sure that you've got excellent solder joints. You want to find the small metal canister with the marking 16,000 on the case. This is a quartz crystal which serves as a time base for your robot electronics controller board. Find the inline socket strip and cut it into one length of 14 holes 2 lengths of 5 holes and 2 lengths of 7 holes. Locate these parts in place on the printed circuit board, holding them from falling out with blobs of press stick. Take care to only solder one pin at the end of each piece of inline socket strip. Then you want to remove the press stick and check that the socket strip hasn't moved slightly or ended up skew. So what you want to do is solder one pin at each end, then check that it's properly in place and lined up properly and hasn't moved, and then when you're sure that the part is located properly, then you can solder all the different pins. The reason we only solder each end of the SRL socket strip is so we can correct and move things around if the strip has moved slightly. If you get a blob of solder between two pins, that could be a short circuit. Remove the blob with the tip of the soldering iron by holding the board up and the soldering iron down. The next thing you want to do is place the microcontroller socket on the printed circuit board, making sure the little half round bite out on the one end matches the silkscreen drawing, where the little notch is orientated towards the bottom of the board. In this video you'll notice that we've speeded up some of the sequences so that we don't end up with an excessively long video. When mounting the integrated circuit socket, follow the same procedure that you used with the SRL strips, using press stick to secure the part in place while you solder. Only solder the 4 corner pins of the integrated circuit socket, then check for alignment, and then complete the soldering of all the pins. Now you can place the tactile reset switch on the printed circuit board. Press this part down firmly until it locates flat on the board and then solder it in place. 100 nanofarad capacitors are marked 104. Place them over the white silkscreen ovals that are marked 104 on the printed circuit board. Then you can fit the 18 picofarad capacitors. They have a marking 18 on them. Next, you want to place the 2 100 microfarad capacitors over their silkscreen markings. Take care to place the longer leg in the plus holes. Solder just one leg of each 100 microfarad capacitor. Then, to get the cap sitting down flush on the printed circuit board, you want to carefully heat the lead and press down gently on the part till it's sitting snug on the board. On the side of the body of an electrolytic capacitor, you will see there's a white stripe with the minus sign in the white stripe, and that's normally next to the shorter leg, which indicates that the shorter leg is in fact minus and the other leg, which is the longer leg, is positive. It's not a good idea to put these parts in wrong. An electrolytic capacitor that's mounted the wrong way around can in fact explode. You will want to wear safety glasses that will protect your eyes. There are 4 female inline headers that need to be fitted to the printed circuit board. They will accommodate Arduino shields if you decide to use these on your robot. The open source Arduino system has a wide range of aftermarket parts like GPS systems, Wi-Fi, Bluetooth, Ethernet. In fact, there's an almost endless range of add-ons. Use blobs of press stick to hold the inline headers in place on the board and perfectly upright while soldering. Again, you want to solder just one pin at each end of these headers, then check if they are vertical and straight. Then you can remove the press stick and finish the job by soldering all the other pins. There are 3 LED indicators that need to be mounted onto your AfricaBot Primo controller board. There are white silkscreen LED markings on the printed circuit board. If you look carefully, you'll see it's a circle with a flat edge corresponding to the flat side on the LED body. You want to fit the power LED, which is green, the LED on digital pin 13, which is orange, and the motor LED, which is red, with the short legs towards the flat marking side on the printed circuit board. If you turn the LED over that the pins are pointing up towards you, and you look at the base of the LED, you will see that one of the pins is nearer to the flat spot on the base of the LED. That is normally the shorter leg of the LED, and that leg is the cathode, which is orientated towards minus. The longer leg on the other side is the anode, which is orientated towards positive. Find the location for the 1000 microfarad electrolytic capacitor. The longer lead must go into the hole marked with the plus mark. Electrolytic capacitors are also usually marked with a stripe down the side. The stripe down the side corresponds to the negative pin, which is the short pin of the part. Now you can fit the power and motor slider switches. If you have switches with the pins bent over at 90 degrees, carefully bend them straight. As with all parts on the AfricaBot Prima, you want to solder the middle pin, then check the part is properly on the board and straight and flush down on the board. Only once you're sure that the part is in its proper place, you can solder the two outer pins to complete mounting that part. There are 4 3-way powered male headers where you will connect devices like servo motors to your robot. You will want to use a tiny blob of press stick on the part to hold them from falling out the board when you turn it over to do the soldering, and to make sure that the part is absolutely straight and flush down on the printed circuit board. And look at the part and make sure that the flat tab on each powered header is orientated correctly according to the silkscreen marking on the printed circuit board. You will want to use a tool like a screwdriver to press on each part and squeeze it down so that it sits perfectly flat on the printed circuit board. Again, you want to solder the middle pin of each of the powered headers, then turn the board over and check that the body of the part is sitting down flush against the printed circuit board before finishing the job by soldering the 2 outer pins. If you solder all 3 pins of these powered headers and the part is skew on the board, it's going to be very difficult to get the part off the board, and you will in fact risk damaging the printed circuit board. Next comes the DC power socket that connects the battery pack to the electronics control board. You want a reliable connection here. Solder only 1 pin of the power socket. Make sure it is flat down on the printed circuit board, and then solder the other 2 pins, securing it in place. The voltage regulator on the AfricaBot has 3 pins. Bend the pins on the voltage regulator to 90 degrees just below where the pins become a little narrower. Press the voltage regulator pins down on the shaft of a screwdriver or something else that you have to hand to get a nice 90-degree bend. Place the voltage regulator on the printed circuit board at the silkscreen marking, and then slip a heatsink in between the regulator and the printed circuit board. The reason why we fit the screw in from underneath is if you use the wrong screw, maybe a little bit too long, it doesn't stick down underneath the printed circuit board where it may clash with other parts like the battery holder, cause a short circuit. Once you've tightened up the nuts and bolts, you want to flip the printed circuit board over and solder the voltage regulator pins. The next item to mount on the controller board is the mini breadboard, where you will make connections and put parts on the robot. Peel the backing off the mini breadboard and stick it in place in the designated area. Now you want to go back to your kit of parts, find the battery holders, and connect an inline female DC plug to the wires. You want to make sure that the red wire is connected to the center pin, which is positive, of the inline female DC plug. Place the batteries in the holder, and at this point you want to hold the wires. If the wires get hot or if you can smell plastic burning, immediately remove the batteries and check the wiring in the plug to make sure there isn't a short circuit. Before you fit the microcontroller chip onto the printed circuit board, you want to connect the battery pack to the printed circuit board and switch the power on and check that the power and motor LEDs light up. If the power and motor LEDs don't light up, there could be a problem with the soldering around the switch. There might also be a short circuit somewhere on your board. With the power and motor switches in the on position and the LEDs glowing, you want to carefully put your finger on the body of the voltage regulator. If the voltage regulator feels burning hot, that means there is a short circuit on the printed circuit board and you need to disconnect power. If the voltage regulator does not get hot, then you want to proceed to the next step, which is to complete a test sheet. You can get and print a test sheet at www.robotscience.co.za. On the circuit board test sheet printout, you will notice there are black dots with no indicated voltage. When you apply the black lead of the probe to the body of the voltage regulator and the red lead of the test meter to those dots, the reading should be 0 volts. If you see a reading of 5 volts on any of the dots that are not marked and are meant to read 0 volts, you need to find and eliminate the short circuit that is causing that problem. The test sheet is also available on the last page of the data sheet on how to build the printed circuit board. If you look at the test sheet, you will need to use an inexpensive voltmeter to check the voltage present at each dot on the test sheet. You want to test the printed circuit board with the power switched on and the black or negative lead of the tester applied to the flange of the voltage regulator. On the test sheet, where a voltage of 5 volts is indicated, the result can be between 4.9 volts and a little more than 5 volts. If there are voltages where there shouldn't be voltages, you could blow the microcontroller. Notice that the bottom right-hand pin of the microcontroller socket should read 5 volts, which should drop down to 0 volts when you press the reset button. The microcontroller used in the open source Arduino Uno controller is an Atmel 80MB 328P-PU. It's a good idea to go to the Robot Science website and download and print out a set of labels. Place a label on the integrated circuit so you will know what the pinouts of the microcontroller are. Place the microcontroller on the board with a half-round cutout marking on the microcontroller matching the silkscreen pattern on the printed circuit board. When you try to place the microcontroller on the board, you will see that the pins do not line up. They are in fact spaced slightly wider than the microcontroller socket. You will need to be wearing an anti-static band on your wrist and place the microcontroller on a flat surface and press carefully down until the pins are pressed up snug against the sides of the body of the microcontroller. You want to do this carefully and on an even surface that the pins are bent evenly. Make sure the pins line up properly and that each pin is locating into a hole on the IC socket before you press the part down. If any pins of the integrated circuit are not locating into holes on the socket, when you press down, those pins will bend and break off the IC, rendering it useless. Once the integrated circuit is mounted on the controller board, you can connect the USB adapter cable and test download a program that will flash the LED on pin 13 to make sure everything is working properly.